sponsors for the day. Um, I try to make sure, like, I attend each and every .NET user meeting since the time I'm in Omaha. Every time I sit there, like, I used to think, like, hey, wow, we've got a very active community of developers here. I receive a lot, I learn a lot. How can I pay back? This is my time to pay back to you guys, whatever knowledge I have. So I'm Naveen Akod, working at Steam Software as a software architect. So let's get started. Today we'll talk about WCF, what's new in WCF as part of .NET Framework 4.5, what are the new features coming up, and how we can take advantage of those. So, configuration. How many of you don't like WCF? Like if you, in fact, there's a website called IHateWCF.com. Really, people don't like WCF because of its configuration. It's the strength and it's the weakness of WCF. You can, pretty much configure anything versus, you can just get lost in that configuration. So, what are the new things? Simplified generated configuration files. In earlier versions, when you create a WCF service and when you reference the client to that service, earlier in versions of WCF, it used to be like this much of configuration, and by the time you end up, referencing and look at the config file, whether it's app file, or app config, or web config, you would be like, what's going on? I've got a bunch of configurations over there. Let me just show you how much of a difference it is in terms of configuration. So this used to be the configuration generated automatically, the moment you reference a service, and
that's a pretty simple one.
This is how it looks like now.
It is simple.
Very, very simple. So these are the changes. With WCF 4.0, there are a lot of changes, but 5.0 has made it much more simpler. So simplified generated config file, WCF configuration tooltips. When you work in, how many times you went into a config file, you were trying to configure something, but you go to IIS, post it, and then you see like a bunch of errors. This is not configured, that's not configured, and you mess around that, or spend a lot of time in that. Now, there's a lot of help and there's a lot of intelligence added as part of Visual Studio 2012 to help you, configure it the very first time and configure it correctly. As part of Visual Studio 2012 as well, there's a kind of configuration validation. So you configure something in the config file, and you try to build that, and as part of build itself, it would show a warning saying like, hey, this is not good. You need to fix that. So that's kind of a cool. You don't need to wait for like you configured everything and then you open the web page and then you see like, oh, a bunch of errors over there. So we look at how how all these things are working in Visual Studio 2012. Generating a single digital file. This is one of the cool things. So if you have a service and if you open a digital file, you would see like it has all the contract, all the APIs, metadata available. But when it comes to what are the entities being used, the digital file is divided into multiple files. If you use the default WCF configuration, WCF client, then the client, downloads all those files and shows you downloads behind the scene and shows you all the details. But if you try to just download it in a browser or something, open it in a browser, then you won't be able to. You need to download multiple files. I kind of came across this one like very we're trying to create a small tool to generate code for mobile applications, automatically generate. So it looks at the configuration, it looks at the digital file, gets the metadata, and generates the code. It was like, oh, I can see everything. Where is my entities? I can see that. So it's in different file. multiple authentication types in a single binding. That's cool. So earlier, your IIS might have basic. Your IIS might be supporting Windows, but if your client were to take advantage of that, then you need to go into the configuration and have two different endpoints for that and two different bindings for that. So now that's changed. So there's a very simplified method that's introduced where like you can say to a WCF like just inherit everything from host, and whatever you configure in IIS, those things would be configured. Earlier it was like you need to configure in WCF and then you need to configure something in IIS. That's changed from 4.5. Default endpoints for HTTP and HTTPS. Just in case if you configure SSL in your web server, then you need to have another endpoint added into the configuration. That was the case earlier. Now, if by default, if your server is configured to have SSL enabled, then the same endpoint will take care of all both HTTP and HTTPS. We'll just have a little demo of all those things. So
1 second. We need that screen on. Will that help you guys?
That'd be awesome.
They're linked together, they should both be on.
What's that?
I know they're linked together, so.
It was on earlier. It's on the screen. There you go, maybe.
So I'll go ahead and create a small WCF service application. So this is just by default. If you look at the config, sorry. We'll see how the what are the kinds of improvements that are there in the IntelliSense. So try go ahead to bindings. So there's something called client credential type. When you select this, you'll get an option inherit from host. This is what I was talking about. So once you select this, then when it is configured, the whole it would inherit all the configuration settings from the host. Once the binding is there, let's go ahead and create a behavior. All right. So once we have this, we have an endpoint and we have a behavior. Let's say you're trying to configure a service. Then what would happen? So here's my new service. I give a name as so. As soon as I as soon as I create a service, you can see it just not even gives me what is the service name, including the naming space that needs to be used. It also gives me if there are any other services added as part of this project, it pulls all those things and it will give it to me. So for now I use this service. It also gives you the behavior one configuration that we created, the one behavior that we created. It also gives IntelliSense on that one. And same with binding one. So that gives us IntelliSense on the binding as well. So it's, this there are little things, but makes life a lot easier for us. So let's say we add a client to this. And we add a service reference. Anyone can help me?
You have to build it. Build the service.
I guess I haven't given a valid address to the point.
There's another behavior section at the bottom of it.
Thank you. Oops. Is that again?
There's a service section too.
All right, let me just remove this. Cool. So I'm just trying to show I was trying to show what's the how simple is the config that gets generated on a client. Okay. Coming to WSDL, earlier we used to have this link which used to show the complete WSDL, but now we have another link that's generated which is called which ends with single WSDL. You click on this and this would generate the complete metadata within a single WSDL file. Okay. So those are the little things when it comes to configuration. Moving on to next one, task-based async support. Asynchrony is implemented deep within the WCF. It's not like we are trying to implement it on a client side or server side. but the way asynchrony is implemented is changed starting with WCF 4.5. Earlier, I mean, when you talk about asynchronous, then you would say like, oh, it returns a I async result, and you would work, create end and begin, and then you would work with that. Now it has changed, like, with C# 5, with the newer .NET 4.5, you got async and await. Those are the two keywords that can be used to have a task-based asynchronous support. So something that's new is implementation. It's based out of TAP, which is task-based asynchronous pattern, and it's based on task and task T result. These are the two types that are there in threading.tasks namespace. So this is used to represent arbitrary asynchronous operation. Earlier, I can, when we were working on a WPF program, wherein we have got a couple of asynchronous tasks that needs to be done, but let's say I've got 3 tasks that I need to fire simultaneously, parallel. But after those 3 tasks are fired, oh wait a minute, I can't decide on task 3 until task 1 comes up, or I can't decide on task 2 until task 1 or task 3 is done. So that kind of used to lead to race conditions sometimes, and we need to manage that in a different manner. So that was real messy. That's going to change now. So I created a simple project for that. So we have 2 projects. One is a service which is which serves synchronous task, and another one is a client. So earlier, I'll try to show you what's the difference between these two. So in earlier version, if you were to create an asynchronous service, then you would create you would create a contract which is like begin, like for example, this example is a calculator wherein like it takes two values and just divides and gives you the result. For that, you would use this numerator, denominator, but apart from that, you would have what's the callback for this asynchronous contract. You would write this, and then the implementation would look something like this. Though you would have this divide async method, which is very, very simple. Earlier, people have gone to great lengths to implement this task-based async support in 4.0 as well. It's not that it can be done, but it's like, they used, with 4.0 fashion, you would create this factory, and but you would certainly need this begin and end methods to wrap this task around the async result. But starting with 4.5, things would change. You would have this I calculator, which is nothing but a very simple contract. But instead of returning, what it returns is like it returns task instead of I async result. Okay, and I have a fault created for that, just in case if the numerator, if it's a divide by 0 error, then it will raise a fault. So very simple. Coming to how the implementation look like. client side, so we have a proxy, and we call the proxy, and we say like over here, we wait for that. You know, if there are two asynchronous tasks that we are trying to fire, over here it's just one task, but if there are more than one asynchronous task that needs to be fired, then you can say like, oh, you know, I fired those 2 or 3 tasks parallelly, but now I want to wait over here. So this await and this async makes all the magic. It kind of takes away all the, you know, all the heavy lifting work out of your hands. So if I run this,
When you opened it, in the service one, you actually drag the
Did I drag
program
something?
SDS down there.
Oh,
Yeah.
so when I run this, let's try to debug this. So in our service, it fires off, and here, even irrespective of it's on server side or it's on client side, I mean, the server might support, may not support asynchrony, but the client might be, you know, try to take advantage of it. So you can use TPL library on the client side, and on the other hand, the server might support asynchronous and the client may not. So you can do vice versa. So it waits for the task. Once that is done, the result that is returned is a task of U8. So that's what it shows here. The only difference is, like, you know, instead of async result and having those begin and edit, you don't need to do all those things. All you need to do is to, like, you know, as if you're programming as a synchronous programming, then you can handle both you know, states, asynchronous states. You can wait. You can say like, hey, here's wait I want to wait using the await keyword, and then it waits till the other processes are done, and then you can continue. So duplex communication. HTTP is a request and response protocol. Like, you request something, then only you won't get a response kind of thing. When you were to have, you know, updates, when client needs an update from server, then like something might change on server and client needs to know, then there are different implementations on that. One is a periodic polling. Every 5 seconds, just like, you know, poll to server and say like, oh, do you have something new? Do you have something new? And the client and the server will say no. And the other method is long polling. You know, you increase the frequency and then it just connects and then just sleeps, waits, and then when the connection is going to be lost, and then again, you know, it connects again. What are the disadvantages of this? One is like periodic polling would inflict high latency on updates. Like, you know, you might poll now at x second, and then at x plus, and the next polling might be like x plus 5 seconds, right? Something might get updated at the server at x plus 1 second, then you won't get the updates for another 4 seconds, until and unless you do the next polling. That's one thing. And long polling, it's hard to implement. People who work on website, they use Comet and other stuff, but it's challenging to implement. And the polling would cause a load on server. It's kind of overhead on the bandwidth and overhead on the server side. So the next thing that's going to come is WebSocket. So WCF also has embraced WebSocket as part of its framework, and typically WebSockets is not a part of WPF actually. It's part of HTML5. It's a standard that's coming as part of HTML5 W3C standards. So we'll see how and what are the supports that are coming up as part of WebSockets. So what is a WebSocket? A WebSocket is a bidirectional TCP channel that allows to have a full duplex over HTTP. Typically, you would need 2 channels to do a full duplex. Channel 1, request and response. But now with WCF, you can open a channel and you can have bidirectional communication, full duplex communication on the same channel. It's a part of HTML5, and it's a new way of communication over HTTP. It's cross domain. WebSocket supports cross-domain calls. You can have a request to one domain, and then you can have a response to another domain, kind of thing. In WCF 4.5, WebSockets are supported in 2 ways. One is SOAP over WebSockets, and another one is plain text. SOAP can be used by, if you have a server implemented with WCF and you have the client, which is also a .NET client, then SOAP works great. But if you are trying to work with the browsers, then plain text is the way to go. There's a new binding that came up, net HTTP binding, that needs to be used if you were to use WCF. And something that can help is there's a NuGet package called Microsoft.WebSockets that really helps in taking the heavy lifting and just get a very neat implementation. All you need to do is just plug in your code into those events and you're done. So let's look at example. All right. So here's a very small service. So the way WebSocket works is like first it kind of starts the handshake on the HTTP protocol, and then it upgrades to WebSocket. We'll see how this is happening, and so what I'll try to do is like here's a simple example. All it does is like it sends the time to the client once the connection is established. So I'm gonna go up fire up this code. So the service is up and running. I'll use Fiddler. So you can see the messages are being pumped from server, okay? But let's see how it is implemented and what's going on behind the scenes. So if you can look at the fiddler, if you can look at the request and response, here you can see it's a HTTP call, right? But there's an upgrade on the protocol is upgraded to WebSocket. So and here as well, the connection is established as a HTTP connection, but then it's upgraded as WebSocket once the handshaking is done. Any questions? All right. So in Fiddler we can have this log. So you can see, if you can look at this, you can see Autobox it is upgrading session 2 to WebSocket. So this is important. This is how, I mean, this is the very basic difference between like the earlier protocols and how the WebSocket is working. Because of this, WebSocket can work, can penetrate in any firewall. Because of 80, it starts as HTTP, but then it changes. So there are no calls, but once it establishes a connection and a tunnel is formed, then all the messages can be floating between client and server. Cool.
Cool.
Yeah.
Awesome. So that was about WebSockets. What are the other new features that are part of WCF 4.5? ASP.NET compatibility mode. The default mode has changed. Earlier it was like compatibility mode was not there, but now with .NET 4.5, the compatibility mode is allowed by default. If you don't want that ASP.NET compatibility, then you need to explicitly disallow it. There's a lot of improvements on the streaming side. Earlier, I think there's a bug in .NET 4.0 and earlier, wherein like even if you disable ASP.NET compatibility, even if you don't want, what would happen is like when you're trying to stream a file, ASP.NET would buffer the file, it would take from the client, it would store it locally, and then present to WCF. That's a bug, but that kind of takes a lot of memory, that kind of takes a lot of time and overhead. That's changed now. I bet that's fixed now. We had a lot of issues around that while going with streaming, and we thought like, oh, let's go with buffering. So with 4.5, the moment client provides the streaming data to the ASP.NET, ASP.NET would be directly handing it over to WCF. So there's no buffering, there is no memory usage by the ASP.NET. New transport defaults for TCP and name pipe transports. You can look at what are the numbers. You can Google it. But something that is really exciting to see is like the numbers are based out of number of cores on the CPU. Okay. Earlier, it was if your CPU is 4 core, it used to only use 1 core. Now the numbers are based out of 4 cores. It would just use all the 4 cores. Out-of-box support for UDP bindings. Do anyone use UDP bindings? Earlier in 4.0, there was third-party packages and libraries available that you can use. You can use for creating UDP bindings. There is a sample from Microsoft as well, but I guess it doesn't work. So now it's like you've got out-of-the-box support for UDP.
What are people using UDP for? I'm curious.
Maybe like you have cameras around, and then you wanna just broadcast something to shut down all the cameras. Then just broadcast using UDP, and then all the cameras are shut down or started. Improved channels and encoding. Has anyone worked with Channel Factory? So if you're not configuring Channel Factory through config file, if you're using the constructor and trying to take control of yourself, then every time there is a connection, the Channel Factory would be there would be a new instance of Channel Factory that would be created. There is no way you would cache that. You would say like, hey, I'm creating this one object and I want to cache and reuse for all the other connections, connections that are coming in. That's changed. They have improvised it, and with 4.5, even if you're trying to code trying to create a Channel Factory using a code with default constructor, you have an option to cache the Channel Factory. And support in WCF, WCF support in Metro style apps. You can use WebSocket, you can use pretty much all these things if you are creating a Metro app. Okay. All right, that was about WCF and new features that are there as part of WCF 4.5. Then I also want to share something that a very cool thing that we created on our product, and we are using it. So we kind of term it as a caching and hashing mechanism. It's a custom solution that we developed. So I would like to thank Ryan Lena. He's the one who kind of wrote this. We were kind of having a discussion, like someone came up and they said, like, oh, our client, it's very slow. They are getting connection timed out, and they're not able to view the page and all kind of stuff. Then what might be going wrong? So the business scenario, and while we look and try to debug that. Challenge was like you have an employee hierarchy, employee within employee below employees and all. So a person who is a base employee with just 5-10 employees below him, he would just get the page right away like this. But a person who is kind of CEO of a company and add to that a multinational company is trying to log in, then the amount of data that comes up is like 2 MB, 3 MB of data, and every time you try to refresh or you try to access that employee details, then you get all the 2 to 3 MB being serialized over the wire. So the challenges was like the page was loading slow, and how to increase the response time, and how to reduce the bandwidth. That was some of the things that we were kind of doing some brainstorming, and I was like, oh, okay, why can't we cache the response? We can cache that, really? Okay, let's see how we try to do that. So the idea that we came up with on the server, while the WCF is trying to send the response, we would take the response, we would create a hash out of it, and send the hash value of the complete response as part of the WCF message. Okay, and on the client side, the client would see like, oh, there's a cache coming, hash value coming up along with the response. So it's supposed to store the hash value. The next time, client would request the same request, would place the same request, it would pass in the hash value as well. So what we are trying to do is like on the server would recognize like, oh, I've got a hash value along with the request. So let me do one thing. I process everything, and once I process everything, I'll try to generate a hash out of it and see like both these hashes are matching. If they are matching, then I don't need to send all this 2 or 3 MB of data. All I need to do is just send the response saying like, oh, you're good. Use whatever data you have. So the data is not changed. Let's look at a little demo on how this is implemented. something that we are really excited about this is one, we already had a WCF service implemented and it's there in production, and we didn't want to change a hell lot of things, but then we want a solution. How can we do that? So here's a very simple thing. I have a contacts from AdventureWorks. It has persons, people, and I have a XML file, and I have a contract, and this contract has two little. This interface has two little contracts: get contacts and get cached contacts. Okay, what's the difference? Not a hell lot of thing. So let's see how the service looks like. So get contacts does the same thing, and get cached contacts does the same thing. All I'm trying to do is load that XML and create a list of object, list of a person, and then send that object down the web. Coming to the client. Even here, I've got two buttons. One button would just call the get contacts, and another button would call get cached contacts. So let's run this, and I'll again use Fiddler. It's near about 2 MB file. So near about 10,000 contacts. Okay. When we look at the response, request and response on what's going in and what's coming up. All I'm trying to do is place a response to the service, and what I got back is all the contacts. Okay. So let's do this again. And try to analyze what's the request and what's the response. So the first request I had is I'm sending 579 bytes, and I'm receiving close to 2 MB back. The second request was also 579 bytes. That's not changed, and this is also not changed. Okay. Same with the third. So every time you do, there's no change. So the server would just say okay, I'm going to process this. I'm going to send you everything. All right. So let's switch back to get contacts. So once I click this, if you look at this, this is actually a bit more. It's 591 bytes compared to 579. Okay. And this will remain same as the other, as get contacts. Now this was our first call. Now let's do another call, and we got it right away. So if you can look at the response, I'm sending 616 bytes, which is not a hell lot, but a bit more compared to 579 bytes. But in response, instead of about 2 MB, I've got 395 bytes, which is a huge difference. So every time now, if the response, the earlier response, we have cached it locally, and as part of the second request, if you can see this message. This hash token is a SOAP header that I'm sending. So I'm sending the hash token as a header, and the header value I'm sending it as a hash value that I received in earlier request. So where did I receive that? As part of the message header, I would have received that hash token. Now every time I kind of do this call, I'm not gonna stream 2 MB of data. It can be anything that it's just gonna be few KBs. So 395, 395, 395, 395. Just in case, what if a new employee or a new contact is added? The server will process everything, and it would go process everything, and it would create a value of the same response, and now the hash doesn't match, it would stream everything. Okay, then you can just replace the new hash value in your in your local storage or wherever you want to store that. Now let's look at how this is implemented and what's going on behind the scene. Okay? Now, as I mentioned, everything was built, everything was developed, the service is there in place, it's there in production. We didn't want to do a hell lot of changes, but then we wanted to have some solution in place. So what we did is when the service request is coming in to the server and going out to the client on the other, that's for the server, and trap the request that is going to the server and response that is coming from the server. So we are trying to trap those two instances and do some magic over there. So if you pay attention to this contract that I have, get contact and get cached contact. The only difference between these two is I have this annotated allow caching thing annotated. So this allow caching thing, gives a flexibility, like out of 200 APIs, I only want 50 APIs to be cached. Other things are just per transaction based. I don't want to do that. So I just go and assign to just those 50 APIs, not others. So what happens with this allow caching, and what the hell is this? Okay. Alright, so it's a custom class which inherits from attribute, and it implements operation behavior. So what are we trying to do here is in the apply dispatcher, we're trying to look at this iDispatch message inspector. It inspects each and every message, and for each message, it goes and checks if the message inspector is a hash inspector or not. Okay, and if it is, then it kind of it keeps a record of what are the operations that are that are being allowed cache, and what are the operations that are not allowed to be cached. So we create here's where we kind of if it is not there, then we add it, we store it, and then we add it to the message inspector. Supporting this, there is another class, hash message inspector. So this class implements iDispatch message inspector. This is where the two methods, like after we receive the after receive request, what should happen, and before send reply, what should happen. So what we do is we try to sniff the header, soap header, and see hey, is there any header that matches with the hash token? And if there is anything, then just let's grab it. And kind of try to look at the header, soap header, try to grab the value of that header, and return that value, which would be available for me in the before send reply. So in this before send reply, just in case if the operation is not annotated as allow caching, then there would be no hashing, and then in the very first line we would just return there will be no processing done. But just in case if that's not the case, if you have a value and then there's a hash value that's sent by the client, then just before sending the reply, what we do over here is we get the message, okay, create a brand new message out of it, because you can't really change the original message in WCF, and read that message into memory, create a hash out of it, using MD5, and then you kind of compare those hashes. So if the hashes matches, then we go ahead and create a brand new message and strip out the body, but keep all the headers and other stuff as it is. Just copy it from the earlier message and create a new message and just serialize that message down the wire. So that kind of reduces a lot of bandwidth. As part of that, we kind of add the new new hash value. We don't know if this is generated now or was it the same hash value kind of thing. So we just kind of use the new hash value and send it as a header, a SOAP header every time. So this is on the server side. Confusions. So we did the same thing on the client side. We have a little class called Cache Message Inspector, which implements behavior extension element. Which inherits behavior extension element, and also implements two interfaces, which is iClient Message Inspector and iEndpoint Behavior. Why the behavior extension? If you look at the app config, this is where we are kind of creating an extension, a new behavior extension, and we are trying to use this. We are trying to configure this extension to our endpoint. So this is being used over in the behavior, and this behavior is being configured to the endpoint. Coming to the class. So what would happen? Again, as I said, it's the same. We're trying to track, what's the request that is being going and what's the response that is being coming to the client. Trap that and work on that, and then make changes on that. What are we doing after? What are we doing before sending a request? Okay, so for demo purpose, I'm just maintaining the hash values as a key value pair in app settings. So I just grab that and kind of look at okay, for this given action, for get cache, I get the action from the header, and then for this given action, is there any hash values? Is there any value stored with me? So I have a bunch of key value pairs, and then if it matches, then grab that and send it. If it doesn't matches, then I would send a header, but instead of sending the hash value, I would send it as a request. Just it can be any term or any word, just for the sake of comparison, so that it's not an empty string. Okay, that's all we do just before sending the request. Okay, but when we receive the response, we try to do the same thing. We try to sniff the SOAP header and see hey, is that hash token available in the SOAP header? And if it is available, grab that value and look for do we have something stored with us? Okay, and if we have that stored, then load from the cache. So it will get into this and it will load the response from the cache, just storing it as a plain bytes, and load it into memory, create a message out of it, and resend the message internally. Everything happens on the client side. So the code, even if this is a synchronous code, but even if you have asynchronous code with begin and end methods, in the end it would come up as if it's the message is coming from the server. And it will return from here. But just in case if we don't have that, or the action stored with us, then we go ahead, serialize it locally. Here, here's where I'm serializing it. The cache response method would serialize it. Then do the same thing, send the method. What happens in this load and cache response? the load response, the response being stored in the isolated storage. So it's only this app that can reach there and then try to get not that you can go to there, but so using we store it in isolated storage. We grab the bytes and create and just return the bytes. The same thing happens in cache response as well. On one side we store the hash token, and on the other side we kind of serialize it and store it in the isolated storage. So the next request that goes, you would look at your app settings and see like, hey, for this get contacts, is there any value available? No, not available. Just send something. And since on the server side there's no allow caching, get contacts is not annotated with allow caching, it would just return the whole data all the time. But when it comes to get cached contact, then it will just return, strip out the body and just return the header and the complete message. So this is what we did, and we're glad it worked out very well. When you get CEO, you would get like this. So, all right. So that was about it. Questions? Thank you, everyone.